The main problem is about 422 million people around the world have diabetes. Our project is about predicting diabetes, so we present a web application depends on machine learning for a fast and accurately diagnose. As we know, machine learning can help people make a preliminary judgment about diabetes mellitus according to their daily physical examination data, and it can serve as a reference for doctors. Also, our website provides some important information about the disease and its symptoms. As we see here, well, let's check the whole. So let's try this. Number of pregnancies. I'm gonna put it as a 0. We're males actually. Okay. Just for testing. Predict. I have a lower risk of diabetes, so if we change this glucose like 200, well that's horrible actually. Yeah, that's just greater risk. Website. We used random forest as our main machine learning algorithm. The random forest gave us an accuracy of 78.8% on the test data, and I think there is no higher accuracy than this on the internet. I mean with the same algorithm. So actually, random forest is better than logistic regression. Also, it's better than the single decision tree. Random forest gave us a lot of importance to the glucose feature, but it also chooses BMI to be the second most informative feature overall. We can see that here. Anyways, our project consists of data science, front-end, back-end for deployment. So let's start with data science file, which includes data analysis, EDA, model building, and saving model using Backend. Well, Jupyter notebook for a better vision, I mean. First of all, we imported the essential libraries we're gonna use, like pandas for data analysis, NumPy for dealing with the mathematical operations, pickle to save the model, matplotlib and seaborn for visualization. Here I just read the file or .csv. As you see here, we got some features like pregnancy, glucose, blood pressure, etc. And at the end we can see outcomes 1 for diabetic and 0 for non-diabetic. Here df.shape to know the rows and columns, .info to know more information about our dataset like data type and null values, .describe to know more information but in a numerical way. Here we just count the outcome like 0. The non-diabetic we're 500, the diabetic we're 268. Here I just made a correlation between all the features before I clean the data. Here I made group the outcome by their name. Here I just want to see the missing values. This particular dataset, all the missing values were given the 0 as a value, which is not good for the authenticity of the dataset. So we gotta replace the 0 values with the NaN value. We can see that here. I just replaced the 0 values with NaN using NumPy library. Here I just renamed the big name, the diabetes pedigree function, to be easier to use. Here I just filled the NaN values with the mean and median. Here I separated data and labels. X was for all of the columns except outcome, and Y was for the outcome. Here I just wanted to see the first 5 rows of X and Y as well. And now we split the data into training and testing data using the train test split function. I bought the data size 35% for the data size, I mean. Then I went for building the random forest machine learning model. So I just imported random forest classifier from SQL, and I put the estimators 205. Then I wanted to see the accuracy of the random forest. Actually, we got 1 with the trained data, and I know that's the overfitting, but in the test data it was 0.788, which is good, super good in it. And now I just wanted to see the important features. As we mentioned before, glucose came in the first step, then we can see BMI in the second step. The last cell is for saving the trained model, so I used pickle.dump, then the name of the classifier, as you see here, classifier, I just used it, and W means write, B means binary, so we are writing a file in the binary format. Okay, that was for the science and machine learning algorithm. We can see the .py. Actually, I'm not a backend developer, but I just I wanted to read some documents about how to deploy the machine learning model, and actually it was very easy. I read some documents about Flask, FastAPI, Heroku, etc., and I found that Flask was the easiest among them. So I just imported Flask, and I rendered the template which contains all the HTML files, CSS files, and JavaScript, and I imported pickle, NumPy, and system. Well, that was very easy. You just type at app.route and you just render the pages you want, like home HTML. It's just like a template. At app.route, you just call a function, then try, except that's all.